Okay, let's take a look at Engaa from 2019, Section 1, Part A Mathematics questions. First question, basic question to break the ice on this paper. Expand the brackets with surds in and simplify. Watch out for minus sign errors, and that simplifies like this. 421. Next. Number 3. Need to make a rearrangement of this equation for x in terms of y. Okay, so we need to step by step make the square bracket the subject and square root and finish up making x the subject, and that's this option down there. Another basic question. 7. Okay, so we've got an equation, got two unknowns, we've got quadratic. It's got two unknown coefficients, p and q, and we're told that the curve of that equation goes through 2 points. What's the value of the difference of those coefficients, q minus p? Okay, well, if we sub in the points to the given equation, we can make two simultaneous equations with p and q, solve those equations, get the p and q, find out the difference, which is 9. Next, number 9. Okay, so a little bit more involved. We need to see which answer down here is the right simplification for the given expression with algebraic fraction in there. So first step should be to factorize the quadratic in the denominator, which factorizes like this. And obviously a clue is one of the factors has to be the same as the bracket on top, or simplification wouldn't go very far. So that factor has to cancel out, which leaves us with x minus 1 in the denominator, cancelling one of the x's as well. So the expression boils down to this one here, and we just need to collect over a common denominator. There's only two options to pick from, and we can see our option is option D. Next, a little bit of a story. Ball for a garden game is a solid sphere. Okay, so sphere of volume 192 centimeters cubed. So we might be thinking volume of a sphere formula, but let's read on. The children's version of the game, the ball is a solid sphere made of the same material, but the radius is reduced by 25%. What's the volume of the children's ball? Okay, so that's a little bit different. If it's reduced 25%, the radius remaining is 75%, so as a decimal point 75. Okay, that would be the length scale factor for that reduction. The volume scale factor would be the length scale factor cubed, so 3/4 cubed is going to be 3 cubed over 4 cubed, so we should know that's 27 over 64, and that's 27 over 64 times 192. Okay, you might think you're in for a bit of a long haul calculation, but 64 actually goes into 192 3 times, which you could spot, or just realize that you're going to need to try putting multiples of 64 into 192 to try and get a result like that. All these answers that are offered are whole numbers, so you know you're going to be looking at a whole number really. So working that out, we get 3 times 27 is 81. Okay, we've got a diagram of a right-angled triangle. The description is reproduced in the diagram. What's the area of the triangle? Okay, well, it's a right-angled triangle, Pythagoras theorem. So apply Pythagoras theorem to the 3 given sides. Reduce that to a quadratic equal to 0. And factorize. We get one negative answer, which we're going to reject because we can't have 3 times the negative for that hypotenuse. So 5 is the answer we've got. And the answer to the question is the area, so a half the base times the height, and we work out the base and the height with our answer for x, comes out to 54. Number 15. PR and QS are the diagonals of a rhombus, PQRS. P to R is 3x plus 2, Q to S is 8 minus 2x. The area of the shape is 11. What's the difference between the two possible lengths of PR? Okay, well, we're going to need to know what x is. So use the given information of area, we multiply the diagonals, half that gives us the area. So that's a starting point. Once again, reduce to a quadratic equal to 0, and we're going to factorize and get two possible values for x, and we put those in turn into PR, and the difference is 8. 17. The diagram shows two congruent right angle triangles PQR and TSR with right angles at Q. Okay, so these two triangles here are congruent, so the same triangle, different orientations. So Q to S must be parallel to PRT. So that's first thing to note. And because if we drop a line here then to make a right angle at the midpoint M, we've got the hypotenuse for that one is this side in RST. So they share that side, which is going to be important. Also, Z angles, we've got an angle shared between those two triangles. And if two angles in two triangles correspond, then so does the third one. So RMS, this triangle created, is similar to TSR. So it's just a scale factor, and that's going to be 4 to 5, y5, because this is a 3, 4, 5 triangle. TSR is a 3, 4, 5 triangle, so the hypotenuse R to T and the hypotenuse RS, they scale, and so it's 4/5 as the scale factor, and in order to get MS, side MS, we scale from the 4, so it's 4/5 of 4 gives us MS. Double it up to get QS, which is what we require. Okay, so number 18. So we've got a block with a hole drilled through it, a cylindrical hole. The block is 100 centimeters long, and there's a square cross section, 22 by 22, as shown in the diagram. We've got a diameter for the hole, 14, and we've got the density of the material of the block is 0.1 grams per cubic centimeter. We're told to use pi is 22 over 7. What's the mass of the block? Okay, well, the total volume, just need a cuboid. Don't forget, 22 squared is 484, just 4 times 11 squared. So using that times 100, we got the volume in total. The volume of the material that was in the hole, well, we need the volume of cylinder, so that's pi r squared times the length. And we work that one out, and then the volume of the block is going to be the difference. So we take the volume of the hole from the volume of the total, so 33,000 for the volume of the block given, and we just need to multiply volume by the density to get 3,300 grams or 3.3 kilos. Answer B. 19. Solid pyramid has a square base, 12 by 12, vertical height h. The volume of the pyramid is equal to the surface area of the pyramid as a number. So what is the height? Okay, it's very nice of them. They've given us the volume of a pyramid formula, a third the area base times the vertical height. So we can do that. That's fairly straightforward, 48h. Surface area, Okay, that's a bit more involved. We've got a solid pyramid, so we need the base area, 12 squared for that square. And we've got 4 faces, and we're going to do a half times 12, so a half the base times the height, and the height, use Pythagoras theorem, the height along the sloping face we need for that triangle. So we're going to use Pythagoras theorem. Here we've got 6 on its base, h is the height, and so it's square root h squared plus 6 squared. So the 4 faces and the base add up to the same number as the volume, which is 48h. That makes an equation. And we gradually bring it down to a quadratic, and we find answer height equals h. And that concludes Section 1 Part A, Engaa 2019 Maths questions.